So in this little lecture on problem V4, I'm going to run through parts 1, 2, and 3 with you / for you, and then I'm going to give you two different numbers of your own, and I'd like you to do the same kinds of work for those two different numbers. So you can't just copy this work, you have to change it to match the numbers that you're using. But everything I do in the next few minutes you should do on problem V4 before you turn it in. The first part, Roman numeral number 1, is contained in your book and is in fact contained in the assignment. It's to find the GCD and LCM of two numbers using the prime factorizations of those numbers. For purposes of this example, I'm going to use the two numbers 68 and 391. This is 2 times 34. 34 is 2 times 17. We have 2 to the second times 17. 391, I happen to know that 17 goes into it because I built this problem. And I also know that it goes in 23 times. That would take a bit of work for you to find out, maybe with a calculator trying different numbers. So we have the two prime factorizations. Now the GCD is a product of some things, a multiplication of some things. And what do you multiply? You take the primes in these two results. The primes are 2, 17, and 23. And you take the fewest of them in any one result. So the fewest 2's is here, and it's none of them, so we don't have any 2's. The fewest 23's is here, and it's 0 of them, so we don't have any 23's. The fewest 17's is a tie, so we use either one but not both. So the greatest common divisor of these two numbers is 17. The least common multiple can be found in a very similar way. You're still looking at these primes, but you're finding the time, the place, and the amount that occurs the most often. So with 2's, it's here, it's 2 squared. And with 17's, it's still a tie, so you use one of them, not both of them. And for 23's, it's here. And so the least common multiple is a little harder to figure out. This is 4 times 17, and that's 68. Times 23, who knows what this is? So the least common multiple is 1,564. The book does a pretty good job of explaining these. I'll try it one more time. 17 is the biggest natural number that divides into 68 evenly. It goes in 4 times, and it divides into 391 evenly without a remainder, and it goes in 23 times. On the other hand, 1,564 is the smallest number that 68 divides into evenly, and 391 divides into evenly. Now, that is what you need to do for problem 1. You don't need to do this next part, and I will emphasize that by erasing the next part pretty soon. Notice how you could use these if you were working on fractions. If you were trying to reduce this fraction, you would divide top and bottom by this greatest common divisor, 17, and that would reduce your fraction for you. On the other hand, if you had some ridiculous fraction problem like this, which is too hard for most people, when you went to find least common denominators, your least common denominator would be this, 1564. So that's an example of how you could use these two important quantities, the greatest common divisor and the least common multiple. But this is the type of work you need to show me when you turn in your problem, which uses slightly different numbers than these. Part 2 is a fact that is always true for any two natural numbers. So what it says is that if you multiply two numbers like 68 times 391, you will always get the same thing as if you multiply their greatest common divisor, which we found in part 1 was 17, times their least common multiple, which we found was 1564. If you go ahead and multiply these, I think you get 26588 equals 26588. And so when you multiply two numbers, you get the same thing as if you multiply their least common denominator and their greatest common divisor and their least common multiple. So then the question becomes, is there a way to use that so that we could find a greatest common divisor and a least common multiple in an easier and faster way? And that brings us to the third part of this lesson. So our plan is to find the GCD of these two numbers not by using their prime factorizations, but by using the Euclidean algorithm. The Euclidean algorithm says if you're trying to find the greatest common divisor of two numbers, divide the smaller into the larger, see how many times it goes. I think it might go in about 5 times. And get a remainder, and then do another division. Divide the remainder into your original divisor. Notice the remainder will always be smaller than the original divisor if you've done your division correctly. So this goes in once. And then do it again. Divide the remainder into the divisor. So it's kind of a string of divisions. And eventually this will hit 0. Believe me, if you do your divisions right, it will hit 0. And when it hits 0, you stop doing divisions and you simply write down this number. That is the greatest common divisor. So the greatest common divisor is 17, and that's a pretty slick trick. That can sometimes be a whole lot faster than what we did on Roman numeral part 1, where we had to do the prime factorizations. It's not always better, but it's often much faster. But then the question is, okay, we found a way of doing this without having to break things apart and doing the prime factorization, but how could we find the least common multiple of 68 and 391? Well, we use part 2. Part 2 said that the two numbers multiplied together, 68 times 391, has to equal the greatest common divisor of the two numbers, which we just found out is 17 using the Euclidean algorithm, times the least common multiple. Now we know what that least common multiple is from part 1, but pretend for a second like it's an unknown. How would we get it by itself? Well, we'd divide both sides by 17. And we would have that this least common multiple that we want to know, even though technically we already know it, would equal this. 17 goes into 17 once, it goes into 68 4 times, and we have 4 times 391. Let's see if I can just do that. I think it's 1564. So we have found that the least common multiple of 68 and 391 is 1564. If you compare this to part 1, you will see that we didn't have to do a prime factorization anywhere at all. And that can save you a lot of time. So again, what is V4? Well, V4 is practice at finding least common multiples and greatest common divisors in many different ways. And why do you think I did a whole extra little lesson called V4 on these things? Because I think they're very important, and that means that most likely you're going to see these kinds of things on our next exam.